Hello everyone, my name is Decheng Zhang. I got my PhD degree from Monash University under the supervision of Professor Ranjith. Currently, I'm a lecturer at Hebei University of Technology. Today, I want to share my PhD experience in Professor Ranjith's group and something about my research. First, I will give a brief introduction about Professor Ranjith. He is a professor at Monash University, which ranks around 58 in the world, and he is the academician of Australia, the director of the Deep Earth Energy Research Lab. His research interests are focused on carbon dioxide sequestration and the exploration of unconventional reservoirs like the shale gas, coal-bed methane, geothermal energy, and gas hydrates. He has a total 470 publications and gets funding over 15.8 million since 2008. And he also got many awards. Next shows our research lab. Ranjith is the founder and director of the Deep Earth Energy Research Lab, and which has the facilities at the macro scale like the city and the macro scale like this triangle setup. With the total value of this setup are over 20 million. This is some of our group photos. We have group meetings every 2 months, and we also get together for big festivals like the Christmas or Chinese New Year, also, or for some big achievements of our group members. Next, I will introduce something about my PhD research and my current research. My PhD research is about the mechanical and flow properties of unconventional reservoirs and the influences of water on them. This is the geology of unconventional reservoirs, which has low porosity and permeability. Therefore, hydraulic fracturing is usually used to stimulate these reservoirs, which will induce the water-rock interactions. I conducted many microscopic observations by using SIM and CT, and also do some mechanical study to investigate the water influences on these properties like UCS, Brazilian tensile, and also the water imbibition test of the TET rocks. Fracturing tests are conducted under different confinement and water injection rates, and the breakdown pressures and crack initiation pressures are obtained. Also, the steady state and whereas unsteady state were conducted on TET rocks. These are the results, and we compare the permeabilities measured by different methods, and also the influences of loading and unloading, and the stress sensitivity of the permeability. Also, different gases are used to measure the permeability, and we also do some sample-dependent characteristics on the permeability comparisons. And also, gas drainage tests were conducted to obtain the breakthrough pressure and to see the differences of permeability before and after the gas drainage. Then console is used to model the gas flow in the experimental test. These are the governing equations and initial conditions, and these are the results. These are the pressure curves in the stepped downstream pressure build-up test, which are validated by the experiments. And these are for the transient test and the influences of the sensitivity of permeability and the reservoir volumes and upstream and downstream are investigated. My current research first is to continue my PhD study to see the dissolption of the methane from keratin and then diffuse to the pores and seepage in the fractures and fracture networks. And then I use CAMSO to do the multi-field modeling to which couples the flow and desorption and adsorption and stress sensitivity. Then I do some macro scale modeling work to see to do the gas adsorption and diffusion in shale nanoscale pores. This shows the shale pores which we can see which is irregular and rough, and also methane is supercritical states at reservoir conditions. We use different methods to quantify the roughness, and then we use the Material Studio software to construct the slit pores with different roughness. Then we model the excess adsorption of methane in this rough slit and also the density distribution in rough pores, in rough slits. And also this is for the seepage flow and heat transfer in rough fractures. I investigated the velocity distribution at the intersections with different branching angles, and also the velocity distribution in fractures with different roughness. Then I built a 3D rough fracture surface to see the pressure and the streamlined distribution in it. Then I expanded to the geothermal reservoir to see the flow conductivity and heat transfer in these fracture networks. So feel free to contact us if you want to do a PhD study, be a visitor, or research collaboration with us. Thank you.